Welcome to the Pragmatic iOS Programmer. My name is Mike Antonelli, and I have been developing iOS applications here at Cerner for about 3 years, and I currently work on the Cloud App Development Platform team.
My name is Musa Hindi, and I'm a software engineer here at Cerner. I've been developing iOS applications for the last 2 years at Cerner. And during that time, we started realizing a few patterns and a few issues come up during the development and maintenance of iOS applications. And in this talk, we'd like to walk you through a few of those observations and issues, and potentially talk about ways that those issues could be alleviated by adhering to some better practices, at least. But before we do that, I'd like to share a story with you. This is unfortunately a true story, and hopefully it will serve as a cautionary tale for those who are here. Some time ago, I decided that I wanted to isolate the sound coming from my speakers at home so that it doesn't bleed to the neighbors' apartments and I don't become that guy in my apartment complex. So I thought to myself, what's the easiest way to do that? Get some foam, put it around the speakers, and sound gets locked in. It doesn't bleed through the walls. So I went into the hardware store and went to the foam aisle and decided to get some foam to actually surround my speakers with. But while walking through the foam aisle, I stumbled upon this can of great stuff. I don't know if it was trying to be ironic, but that's what it said. I mean, I'm not really making this up at this point. It was a can of foam that basically allows you to mold your own foam. So I opted for the idea of, hey, why don't I make my own foam instead of buying pre-made foam? So I went home. I started making some foam molds to surround my speakers, and I used the awesome set of tools of cardboard and plastic knives and sporks and whatever I had at that moment, and I made my mold, and I was really happy with it. I put it out to dry. After a few hours, grabbed it back, and it was good, but it wasn't really the right shape that I wanted, so I started to try and manipulate the shape of the foam so it can better fit what I needed it to do. The moment I tried to poke it, it literally exploded in my face. And this guy actually looks a little bit better than what I looked at that point, so it wasn't such a great experience. I'm hoping none of you actually had the same experience, but I'm pretty sure this story is kind of familiar, and you can draw analogs from it. Invariably, this is what happens when we embark on any type of project. Typically, we stumble upon the tools that we have and end up using either the wrong set of tools or misusing the tools that we have. We rarely understand the medium in which we're working or that we're working with at the time, and more often than not, we use really poor judgment in our planning and our designs. Also, being stubborn as we are at sometimes, we never actually reference the communities and reference what's being done or even read the instructions. So we really end up in these settings where, for lack of a better term, end up with things exploding in our face during the process. So to start us off talking about tools and how that fits in the process of iOS development and maintenance, I'm going to hand it off to Mike so he can walk us through that a little bit better.
Thank you, Musa. So every craftsman has a set of tools. Arguably, every great craftsman has a great set of tools. But it could also be argued that every terrible craftsman could potentially have a great set of tools at their disposal. We, as craftsmen, don't just cut code, develop code, automate, or document. We do all of these things every day. So it really helps that we would understand what tools are at our disposal. And it would fundamentally be purposeful to start with our core set of tools. So the first core set of tools that we have as iOS developers is the operating system. Mac OS X provides us with many great, as Tim Cook would say, Mac applications. Now, that's anywhere from Mail to Outlook. I saw a Microsoft application go up in WWDC. But anyway, it also gets you things like Git, Terminal, the digital color meter, if you've ever used that to pick a new RGB value off your screen. But then we also have Xcode. Now, many people have come from other programming languages, and Xcode might not be your favorite IDE. Unfortunately, it's the primary IDE that is used for developing Objective-C. Now, there are other IDEs available, such as AppCode, but this doesn't give you things that like gauges and interface builder. Now, we've also got the iOS simulator. although the iOS simulator does not exactly represent our device, it gives us a great idea of what we're going to have in at least close to a production state. Then coupled with Xcode and the simulator, as well as potentially the device, we've got instruments. Now instruments are going to provide you the opportunity to use things like allocations, the activity monitor, and what you're going to be able to do is actually see what's happening in your application and better trace it over the threads as it's occurring. And some of you might be confused to see Safari up there, but if you saw our talk last year, non-native workflows in the native world, we saw that when you're using a native application as well as a hybrid application, you sometimes use web views. To debug these web views, you can actually use the developer toolset that's in Safari, and you can use the web inspector to inspect the DOM in real time, as well as inject CSS and inject JavaScript to see what would happen instead of having to go write a ton of code and deploy it first. Now, the next set of tools that we should probably get to is source control tools. Now, you'll see that Git and Subversion are both up there, and it's unfortunate that Subversion doesn't have the greatest support in Xcode. If you actually go to Google and look up if you look up Subversion and you look up Xcode, the top post that you'll see is the most frequent releases of Xcode and the phrase, how do I get Subversion to work in Xcode? Now, Xcode actually provides great support for Git, but it's not the best. So, one of the things with neither having great Xcode support directly, we have to look elsewhere. Now, one thing that we have to be aware of is that Git is not GitHub. A lot of people's first experiences with the Git source control system is with GitHub. So anything that you find frustrating about GitHub isn't necessarily because of Git. Now, why does this have anything to do with being a pragmatic iOS programmer? Well, it really is the idea that Git is not GitHub. We really need to understand our core tools and not just be handed a set of tools and be told to use them. And as we onboard these tools, we do things even further. Now we look at unit testing. So Apple suggests that we use things like XCTest in place of the older deprecated OC unit. Now, Xcoverage is an application that allows you to see your coverage files if you were to go into your target and configure your application to output coverage reports, to generate test coverage files, instrument program flow, and generate the debug symbols. You'll be able to use this application to not only see the overall code coverage of your application, but actually see the implementation files and see what implementations you're not actually touching. Someone wise once told me that a piece of code becomes a legacy piece of code as soon as you release it without an integration test, a unit test, or an automation test. I think that's great advice. So if you're not testing your code today, I highly suggest it. However, unit testing is only a piece of the framework. We need automation testing as well, and we've found this here at Cerner. So automated testing framework Appium allows you to test iOS applications, Android applications, and you'll see in the list that it also supports Firefox OS. So what this does is it allows us to test in an automation not only the native applications, but our hybrid applications like I was discussing earlier with the Safari Web Inspector. So this can occur on both the device and the simulator. If you're looking for more information on Appium, there was a session this year called Addressing Challenges of Testing Mobile Apps via UI Automation that I highly suggest. So now we get to continuous integration. We have people that we can blame or find more responsible for an issue when checking into a source control system, and tests to actually alert us that something failed when someone did so. So one of the most familiar continuous integration systems that we see today is Jenkins. In the enterprise, Jenkins is very popular because we are afforded the opportunities for additional hardware that potentially the open source community wouldn't have. Originally started in 2004 as the Hudson project, Jenkins was officially released under this name in 2011. It's got plugins for almost anything under the sun, and if there isn't a plugin for it, you can write one yourself. The next tool that we see is one of the primary continuous integration tools in the open source community, Travis CI. Now, if you do use GitHub, what this is going to do is if you actually add a .travis.yml file to your project and set up the configuration at travis-ci.org, you're actually going to start monitoring your application like we have for GitHub hooks for Jenkins. So when I open a pull request in an attempt to contribute to an open source project, the first person to respond to my pull request is going to be Travis CI. When I opened that pull request, it kicked off a build job, and at that point, it actually tested my code against the existing integration test scripts, as well as any possible regressions that I might have introduced in the code base. Next, we have bots. Now, this was given to us by Apple at WWDC last year, and we got dashboards and we got Xcode integration, but that was about it. So although it does have the integration directly in Xcode, it hasn't been widely adopted because we don't get things that are afforded to us by Jenkins and Travis CI, like pre-install hooks, post-install hooks, and actually do things that we find meaningful as developers. So now that we've got all these, there's additional plugins that we can put on top of this core set as we identify gaps. This specifically is called Alcatraz. You can find it at alcatraz.io, and it is a package manager plugin for Xcode. It does everything from code linting to GitHub plugins to documentation utilities and theming for Xcode if you want a different theme for any reason. Now, they have more than 150 plugins, and it's just as simple as going to Window, Package Manager, and you can install a new plugin. Now, I know we don't store too much persistent data here at Cerner, but I think we should also talk about the core data editor. Now, if you've ever dealt with core data, the APIs are hard enough to deal with, so that seeing your data and making sure it's there, you're not quite sure if it's your use of the API or if it's actually your data not being persisted. So core data editor is a GUI that allows you to view and edit your application data. It's both Mac and iOS compatible, and it manages both XML and SQLite stores. So this also lets you create and generate your object models. Now, this is something you can get for a 15-day free trial, and then I think it's $30. But if you're using core data on a day-to-day basis, or maybe you're new to core data, I would at least suggest using the trial while you're learning how to use the APIs. Now, no tooling discussion regarding iOS would not be complete without CocoaPods. CocoaPods is a dependency management tool that claims to have thousands of libraries ready for use in your application. It allows you to not only add these libraries to your application, but also to develop libraries that can be used in other people's applications. Now, you get something called a pod file. Essentially, it starts off as an empty file. You can go into terminal and type touch pod file. In there, you'll see that one of these libraries that we can use is AF Networking, and I'd like to use AF Networking 2.0 and trust that version optimistically. This is something that we see in gem files fairly regularly if you're familiar with the Ruby language. Now, I've added AF Networking, and I can see that a new pods target has been added to my project. I've now got access to all of the headers that AF Networking has provided, and however, this also requires the CocoaPods gem, it requires Ruby, and then Ruby usually is installed using RVM. So it sounds like there's a lot of cost to this, but we also get a lot of benefit. So what we need to make sure we're doing is we're using these tools, because the ones that I mentioned is only a very small subset of all the ones out there, is that we need to evaluate these tools. When you're using an open source tool, it's quite easy to evaluate by opening up the GitHub page. Here in the example, you should be able to read it. We can take a look and dive deeper into the number of the contributors, the actual number of issues, the last commit date, how many releases they've had. Ultimately, what you want to make sure is you're not going to run into being the maintainer of a tool that you're the only one benefiting from. Is it really worth all the cost of maybe taking other people's bugs and fixing them to actually just have a solution that might be solvable by another tool? So the future. We just found out on Monday that iOS 8 and OS 10 Yosemite are coming. Well, how do I, as a developer, prepare my tool set for the future? So we can install Xcode 6 and the iOS 8 SDKs side by side if you've got Mavericks installed, the current stable version of OS 10. Now, that's nice, but as Beta 2 comes out, Beta 3 comes out, you're littering your development environment with many things that might not potentially go in the final release. Now, there are some features of Xcode 6, like new bots features, that require OS 10 Server. That new version of OS 10 Server also requires the new version of OS 10 Yosemite. So when you run into issues like this, what you can use is things like disk utility to actually create a separate partition that allows you to help create a future development environment. Now what this means is you can essentially switch from one to the other and future-proof yourself, install your tools, and make sure everything's working as new versions are coming out so that the day the production release of OS X and iOS 8 drop, you're not just getting started with these things.
All right. So talking about the future, it's very important also to refer to the present state. And understanding the present state requires a good understanding and grasp of the inherent nature of the platform and the language that we're using. And to be an upstanding citizen, it's very important to also adhere to whatever conventions have already been established, whether they are by the regulated established conventions or things that have just been agreed upon based on community contributions. These conventions stem from simple things like variable names. So, what convention should we be using for naming our variables in our iOS code? Should they be snake case or should they be camel case? Typically, they're camel case, and that's not really enforced, but that's agreed upon in the language. Additionally, this also extends to our method naming. Now, method names are really crucial. And there's a specific type of convention that we see sprinkled all over the native code that's already available in the iOS SDK. But moreover, if you look at it, it's kind of verbose, but not only does it convey meaning and intention, but it adds some sort of modifiers to actually assert exactly what's going on. Looking at the application did enter background method, for example, why not just write it as application backgrounded? Well, they're the same thing, and for all intents and purposes, it could just be the method called A. But here, really, what we're trying to convey is some timeliness, and therefore, adding some modifiers and qualifiers like did, for example, here, asserts to the developer the stage in which the application is while it's going to the background. These are good things to actually stick to while defining your own method names so as to convey your intentions to your consumers at that point. But having said the conventions that already exist, it's very important that even if something is found in other languages that might be beneficial for the purpose of Objective-C code, we don't want to litter it with conventions that don't make any sense. A common convention, for example, in Java development is we define interfaces of a specific name and then implement them by appending an IMPL at the end, or implementation at the end. Well, not only is this not a typical convention, but it actually limits the scope and scalability of your classes. Here we're actually, by saying that this view controller is an implementation of the refreshable protocol, we're hiding what it actually is, and we're actually limiting what it can do in the future. And this is really redundant information because what it can do, or its responsibilities, are defined by the conformance set that is defined between the angle brackets. So why is this important? The idea is we want to establish a collective vocabulary and a collective wisdom for the ability to actually convey our intentions properly. But even more important than that, we don't want to be reinventing wheels. If things already exist that do the functionality that we want, there's no need to actually create those from scratch. Whether that's actually a UI component that's already been defined, something as simple as these components right here, or even more complex, like image pickers and map views. These already exist in UIKit or MapKit or their corresponding frameworks, and are just merely drop-ins that we can utilize and leverage in our code. This also applies to actual source code. So the basic foundation classes, for example, have a number of useful APIs that enable us to do a lot of good functionalities and manipulations to these objects. Things like base64 encoding, for example, I know a lot of us have written that from scratch at one point, but at the moment that it's become available, it's very important to actually start utilizing the basic agreed-upon implementation so as to benefit from any future optimizations or benefits that come from implementing this without having to worry about things breaking our end or our code becoming really old and useless. But then we actually want to provide custom functionality. Well, in the event that we want to have custom functionality, it's better to actually extend what exists rather than reinventing it from scratch. And that will actually enable us to gain custom functionality while leveraging what's already been done and all of this energy and knowledge that's been available. Extending functionality in iOS or Objective-C in general can happen in a lot of ways, and we typically do that by subclassing. We do that by adhering to protocols or conforming to protocols. But one of the better ways to actually do that that's really, really nice and elegant is using categories. By using categories, we can actually define custom behavior on existing classes, whether we actually wrote those, or they're available in the foundation sets or UIKit or everything else. So, for example, here, we can offer some helpers on the NSState and NSString classes by adding these methods. Now, this extends the core functionality of those objects, but categories are actually more powerful than that. We can actually use categories to extend the behavior of some object to actually show what it can do in the context of another object. A good example of that we find is the NSString drawing category on NSString. Now, NSString by itself is actually defined, or the majority of its headers are defined in Foundation. But we can, if you look into UIKit, you'll see that there's an NSString category for drawing NSStrings. This is actually logical because the function of drawing a string is probably more the responsibility of UIKit than the core responsibility of Foundation. So by this, we can see that we can offer representations of objects into other objects by adding categories and these extensions. Well, we can also do that in our own code. So let's assume, for example, we had a person class, that person class having the basic attributes of first name, last name, and date of birth. And we wanted to actually show that person object and have it be displayed in a table view cell. Well, we have a lot of options here. We can actually define the table view cell to accept passing that person model object dependency into it, and then that view class, the UI table view cell, configures the view to actually represent what the person object should look like when represented in the UI table view cell. That's one way to do it. Another way is we can delegate the entire configuration of what that model object looks like in the view object to the data source method or some helper method in the same class that actually conforms to the UI table view data source protocol. There are two problems with those implementations, however. In the first instance where we're passing in the model object into the view, we're actually having the view be more responsible for what it does than what it should be responsible for. We're actually giving it more knowledge about the environment around it than is actually necessary or needed. It now has more business logic tied to the view than we would have actually liked before. And that actually becomes a bigger problem when we want to start doing some unit tests where we might want to operate in an isolated environment and not have everything being pulled in. The other case, obviously, the data source method implementation, we end up littering the data source methods with business logic that really doesn't live there. So what's a good alternative? Well, leveraging the category extensions, we can define a category on that person model object. And we can define it within the context of the person table view cell. In this case, we're saying, I want to actually ask that model object via this category method to configure the cell that is going to be represented. This is kind of what Objective-C deems as decorating those objects to extend their functionality to be represented in other objects. Now, the data source method obviously has to stay there, but now all it does, it delegates the task of saying what that model object looks like in the view to that configuration method that we've defined as a category. And this can actually extend to a lot of things. So we can have a person model object define categories as to what that person expects to be presented as in multiple different views or different contexts. So it's obvious here that we're starting to think of going from just thinking about the nature of the language to thinking about design and thinking about architecture. And the idea about design is you can't really future-proof anything to the extent that you can actually predict what's going to happen, but always assume that things are going to change and make the code the easiest to change in the event or in the inevitable event that change actually happens. The main design paradigm in iOS is Model View Controller, or MVC. And obviously we've all seen this diagram. Basically, the views and models don't communicate with each other directly. The communication happens via a controller. When the view needs to actually be updated, it calls on the controller to actually call on the model to tell it what the view needs to look like. And then the view gets inputs or gets events that get conveyed to the controller that then update the model. However, by saying that the design paradigm and objectives in iOS is Model View Controller, that ends up in a problem. So are all iOS objects really models, views, or controllers? Are those the three buckets that we only think about? Perhaps, but what about these guys? We have a slew of different, at least object class types that really don't necessarily fit completely in one of those three buckets. So if we end up arbitrarily fitting those in those buckets, we end up actually defining our applications in the context of Model View Controller, in contrast to the domain, which actually defines what those applications do. So going back to the question, are all iOS objects models, views, or controllers? The real answer probably is no. Models, views, controllers are a subset, and maybe a major subset of the objects that exist in Objective-C. So with design in mind, some time ago, Mike and I were fortunate enough to work on the Kiosk project. And from at least what our usage stats say, I think a lot of you have probably used it at some point or the other. One of the sections in the application was basically an appointments view controller that displayed a nice carousel of appointment cards where you can pan through to see your appointments and then check into the appointment that you're in for that day. Well, this was a very nice view or module, and just like a majority of our projects, even though they look nice on the outside, they're not without fault on the inside. So this view controller suffered from big view controller syndrome. It was a huge file that had over 700 lines of code. It had code that was tangled, and the code was really, really hard to read, and any time that we actually wanted to change anything, we ended up breaking something else. And it's obvious to see why that is. Not only was it long, but if we inspect the header a little bit more, we see that it was explicitly saying, I am doing too much. It was data sourcing and delegating to the carousel. It was delegating to the appointments retriever, delegating to another retriever, and so on and so forth. So it's telling us I do too much. Additionally, if you go into the implementation, it's even worse. We were pulling so many dependencies into this class, which meant that we are using these dependencies in one way or another inside of that class, which meant anytime those change, it's going to break our class. And anytime we try to change their usage, we end up pretty much breaking that class. So it wasn't great, and I think we ended up even putting a sign on the wall to say, I will not recreate the appointment view controller. That was our mantra for pretty much half a year after we wrote it. So let's look at this from, take a step back and see what this appointment view controller is actually doing. If we notice, it's doing a lot of things. It's actually holding a lot of responsibilities just by what it conforms to in terms of protocols. Well, we can tell by just looking at this that these responsibilities are just suffocating and just are eager to breathe out of the tyranny of this appointments view controller. So what if we did just that? What if we actually took those out and put them in real objects, made those kind of fake responsibilities inside of that view controller into real objects outside of that view controller? Well, that's probably a good first step. I mean, we start to identify that we can now put these responsibilities in separate objects. But after we do that, we realize that they were in the view controller for a reason. They actually needed something from that view controller. Well, we can start then saying that the view controller needs to communicate with these objects via some interface that both of them define reciprocally. So by doing that, we start putting things where they belong rather than actually arbitrarily stuffing them in the most abstract of MVC classes, which is the controller. After some moving around and some other shuffling of code responsibilities, we end up with something like these classes. Now, this is one permutation of what it could be, but we could define things like managers, for example. I mean, managers in this case would just have the sole responsibility of being delegated from the view controllers as to what they should be doing. Now, looking at this, we can then go from something like that, where it was doing a lot of things in the view controller, to a view controller that actually is composed of those managers and can truly delegate to them what it wants to do. But wait a second, isn't it just moving code from one spot to another spot and just kind of splitting it up into files? Perhaps, but the problem, the benefit here is we end up truly separating concerns and designing our objects to be more modular. This actually makes our things better for the purpose of change and extension and evolution as they go on. Moreover, when things are cramped up in the view controller, which by probable definition is non-reusable, we can't tell what is reusable. We might have some reusable gems in there, but we can't tell until we actually extract those out, start doing that refactoring, and identifying the points of reuse for the purpose of actually reusing that in multiple other incidents in our projects. Ultimately, this is for the purpose of maintainability, and it actually helps us collaborate with our contributors.
This is a public service announcement. Every human is supposed to get 64 ounces of water per day, so we just want to make sure Musa takes a break real quick. I don't think I was supposed to make him laugh like that.
I'm actually trying to drink water. Okay. So we talked a little bit about, about dependencies. Now, the problem with dependencies is they're finicky beasts. Sometimes we end up with, this tangled dependency, mess where we have dependent code that we wrote that relies a lot on finicky, unstable, jittery dependencies. At least the definition that I like to use for an unstable dependency, it's a dependency that is evolving and changing very rapidly. It's something also that we don't control. It lies in someone else's code that's either inaccessible directly or just we can't do anything about it once it changes. And the problem with that is when a non-passive change happens, then that ends up in us making changes in up to and places where it was actually used. Well, that's a problem if that's a problem if it happens one time, but imagine if it happens multiple times. That ends up in a very, very hard tangled mess, and it makes it really, really brittle in terms of maintainability. A possible way to fix that is to inject some stable code in between our consuming dependent code and that unstable dependency. This code in between is, in contrast to that dependency, stable, meaning we have control over it, so we control its implementation and its interface, in addition to the fact that we'd like to make it unchangeable as much as possible. So the idea here is we want to expose stable code and isolate as much as possible unstable code. An example of that is what happened to AF networking. A migration happened from the version 1 to version 2 of AF networking, where there were a number of classes that actually shifted. The main class that existed in AF networking in version 1 was the AF HTTP client that defined a number of resource request methods in that class. When they went to version 2, the methods kind of changed, but the big change here is that class that existed before doesn't even exist anymore. The whole object now doesn't exist. So both the methods and the object change. Well, to protect ourselves from a potential change like this, we can define something like our own client that sits in between our dependent code and our dependency code. That defines basically more or less a domain-specific interface that defines the way that we want to consume that dependency. In this case, if you notice also, even though the methods mirror what was in AF networking, but we don't expose AF networking past that step. Maybe just exposing status codes is not sufficient, and maybe it's better to actually pass back some composite object that actually demonstrates the cohesion between the different things that we want to pass back. But at least it's a better step than actually exposing something up a level where it might end up basically exploding in our face in the event where it changes. So back to the initial sentiment. The idea here is we want to utilize a collective wisdom for the purpose of exposing the intentions of the code, ultimately for better maintainability, collaboration, and communication with members of our community. And to talk to us about community and to bring this talk home, I'm going to send it one more time back to Mike.
So to be pragmatic also means to be part of a community. This is people stuff too. It's not just all technical. So the obligatory Webster's definition is up here, but ultimately to be part of a community means that you share a set of ideals and goals with another group of people, either one or more. I guess you could have a community that was two, but we tried that for a little while and it's a little bit hard. So as you're developing your pragmatic rationales, you're gaining your own opinions. These opinions may not align with the entire community. So what if one of these interests or goals deviates and you want to bring it back into your community? Well, it's not going to be the first time that ever occurred. Everything that I've been told since I was little is everything starts with one person. That kind of you can be whatever you want to be stuff. Well, your views and judgments can deviate, but how can we actually convince others to follow us? Well, it all starts with alignment. You might already be aligned with your team, and that's great, but what do we mean by alignment? Alignment can be as simple as using the same words, describing the same design patterns, or just enjoying each other, for a beer in the afternoon. You want to make sure that you guys are able to communicate back and forth so that when you actually try to oppose something, you're not the first guy in the room saying something and it's the first time that they've heard from you. So you align with your team and you understand the greater rationale at this point. Then you and your team, if for whatever reason are siloed or separated from your company, then you align with them. Your company in this situation is not necessarily the corporation you work for, but it's the company that you keep. If it's another team that you work with or your team works with, then that's your company. Now, with great alignment comes great power, and someone once said with great power comes the ability to win at tug of war. So now that you've got alignment and everyone's in the same corner, you're able to oppose the community, whether it's internal or external, but propose what you deem to be a better solution. Now, when you're communicating and you're opposing a community's way of life, timing is key. You're not going to pick a release day or the day that you're troubleshooting a production issue to walk into your boss's office and say, I think we should be doing something different here. Unless maybe it was the reason that you're having the production issue, then maybe you're right on time. Now, when you get everyone in your corner and you're aligned, and maybe the entire community or a subset of the community decides to take what you're saying and go with it, you're going to be able to drive change. Now, what do you get to do by driving change? You get to be very selfish. Now, the people up here are selfish, but being selfish kind of has a negative connotation. To be selfish isn't always a bad thing. To be selfish, like you see up here with Facebook, now, they have one of the biggest open source communities, I think, on GitHub. I think they have more projects than I've seen any other, I guess, big corporation put out. But what they've done is they've actually released everything from an LLVM compiler utility to what we heard about this morning in the keynote for open hardware. Now, what this allows them to do is get everyone in the room to use their devices, I guess if it's the open hardware, their software stacks, their APIs. They get told that something's wrong, something that they might not have known. Now, the other icon up here, if you're not familiar with it, is a blog called NS Hipster. It's actually one person, and it's one person that pretty much has a hand in almost everything in the open source community for Objective-C. His name's Matt Thompson, and he gets to be very selfish. He writes so many articles that he actually appears higher in Google when searching something like NSURL connection or NSURL session. You'll get linked to Matt Thompson's blog before you'll get linked to Apple's official documentation. Now, what that means is he's able to actually drive change and be selfish by putting his own utilities out there. In many cases, they're great, and in some cases, they might not be. But he's able to get you using them, and he's able to get feedback. So individuals are driving change by their active presence in the community, as well as corporations. So here we are. Whether empowered by a corporation or as an individual, we're now using the right tools, understanding the nature of the medium, we're applying great design and planning, and we're contributing to a better community. So you, the pragmatic iOS programmer. I'd like to share an excerpt that I think really describes you. You try to capture elusive requirements and find a way of expressing them so that a mere machine can do them justice. You try to document your work so that others can understand, and you try to engineer your work so that others can build on it. What's more is you do all this day to day while fighting against the project deadlines. There is no such thing as a best solution. There can only be systems that are more appropriate in a particular set of circumstances. Your background stems from an understanding of basic principles of computer science, and your experience comes from a wide range of practical projects. You adjust your approach to suit your circumstances and environment, and pragmatic programmers get the job done, and they do it well. So don't be this guy. Be this guy.
We might have a few minutes for questions if you'd like to ask some questions.
Thank you.